Next page. Let's talk about possibilities. If we are given the SSA case, that is side-side angle. That means I give you two sides and one angle, and you need to figure out the rest. This is a very tricky situation. So, given that angle A is obtuse, what does obtuse mean? Greater than 90 degrees. Side AB is shown. Okay, so you can see this angle is bigger than 90. C has to be somewhere on the dashed line, obviously. Okay, let's say that C is here. You draw a triangle. If BC is longer than AB, how many different triangles can you make? B. If BC is the same or shorter than AB, how many triangles can you make? Okay, so talk to your partner. How many different triangles can you make? Okay, if BC is bigger than AB, then you guys all put infinity, right? I guess what I'm asking for is BC is a set length, like this long. Okay, if BC is this long, how many different triangles can you make? One. Okay, so I'm not really sure how other ways I can ask this question, so every year people get really confused. Sorry about that. I'll try to think of a better way to ask next year. So I guess what I'm asking is if BC is this long and that length is longer than AB, how many triangles can you make? Just one. If BC is the same or shorter than AB, how many triangles can you make? 0. You can't even touch the line.
Oh, you have to touch the line?
You have to touch the line because the angle is fixed. I can't change that angle. Okay. All right. Let me try to ask the next question a little better so then there's less confusion, but okay. I'm a little bit not sure if I can ask this better. Okay, next. So that was the previous question was when A is obtuse, meaning it's greater than 90. If A is acute, what does acute mean? Smaller than 90. If it's smaller than 90, or equal to, smaller than 90. Okay, and then side AB is as shown, and then H. H means the altitude, so that is a right triangle. It is perpendicular to that dashed line. C has to be somewhere on this dashed line. 4 cases or 4 questions. If BC is H, how many different triangles can you make? Don't say anything. If BC is shorter than H, how many triangles can you make? If BC is in between AB and H, meaning it is a length like this long, okay, one set length, okay? I'm not talking about infinitely different ways of making BC, just this one length, but it has to be this long, and it is in between, the length itself is in between AB and H. How many triangles can you make? Okay, so saying C is on the dashed line. Okay, then last one, if BC is longer than AB, if BC is longer than AB, how many triangles can you make with that length of BC? Okay, go ahead. Go with your partner. A, B, C, D. If BC is H, how many triangles can you make?
1.
Okay, because that's just a right triangle. If BC is shorter than H, how many triangles? 0. Too short. Can't even reach the line. Okay, C is a little bit difficult. Hopefully I can explain this well. If BC is a length, and that length is between AB and H, how many different triangles can you make? Of course it's infinity, but it's just if it's this length, this very fixed. If BC is this length that I cannot change.
Why you cannot change it?
That's just the question. If BC is this length I cannot change, how many ways can I make this triangle? 2. Why? Okay. Let's look at this. If BC is a length that is in between AB and H. That is this long, right? You can see this length is between A, B, and H, right?
So you cannot change the length.
You cannot change the length.
Oh, okay.
You can see that it can also go this side, right? So we can create two entirely different triangles with very different angles. Can you guys see that? So I can create one triangle here that looks like a very thin one, and then I can also create another triangle here. They both share the same A, the same AB side, and the same BC side, but they look very different. You guys got it? So this is the case we have to discuss today. But let's look at the fourth case. The fourth case is that BC is just a lot longer than AB. One, because there is no other way to put BC. Now you might say, oh, if BC is a lot longer than AB, why can't you just go here? Because A is fixed, right? You can't move this side to this side. Now the angle is not acute. Okay. Ugh, that was a hard one. Okay, so this is 2, this is 1. Okay, let's look at a case. Side angle. Solve triangle ABC given that A is 7, B is 6, and angle is 26.3. Side angle. So let's go ahead and draw a picture. Let's go this way. A, B, C. Side A is 7. Side B is 6. Angle A is 26.3. The question we must ask ourselves is this the only way I can draw this picture? Or is, one of the side, can it swing to somewhere else? All right, so we know side 6 is fixed. Angle A is fixed. 7 can maybe move. We don't know. Right? Can I draw 7 so it's like this?
No.
Can I draw 7 only this way?
Yes. Can we use a taxi?
So the question is 7 in between the altitude and that side so that I can swing in between? Are you guys with me?
Can you repeat it?
Okay, so the question is this side 7 short enough so that it's shorter than 6, it's inside here, but longer than H? Is this side this long so that it could be here and here at the same time?
But he asked for solving
So the thing is, are there two ways to draw this triangle so that the angles could be obtuse or acute at the same time? No. Okay, but how do you know for sure? We had to find H. Okay, so how do you find H?
Sine, cosine.
Yes, so notice that this is a right triangle. This is a right triangle. This angle is 26.3. H we don't know. We know 6. So what kind of trig function is that?
Cosine.
This is the opposite side to this, and then this is the hypotenuse side. So what trig function is that? Sine.
Oh, sine. Oh, yes.
Okay, so sine of 26.3 is equal to opposite over hypotenuse. Okay, so we need to figure out what H is. H is 6 times sine 26.3. Okay, so go ahead and figure out H. Okay, so what value is H? 66? Okay, 2.66. So is there any way that the 7 is in between 6 and 2.66? No, no way. So this 7 is actually really long, and it's even longer than AC. So this is the only way to draw this triangle. So find all of the missing angles, A, B, C. A, B, C. Okay, so go ahead and use law of sines and solve the triangle. Okay, so let me give you the answers. This is B is 22.3, C is 131.4. If you are not getting that, double check to see if you did it right with the closing parentheses and stuff like that. And C, side C is 11.9. Is this wrong?
Can you just show us
How I solved it? Okay. All right. Here's what happens. Okay. All right. Sine 26.3 over 7 is equal to sine B over 6. Right? Cross multiply solve, so angle B is 22.3. Is it not?
Yeah,
22.3. Right.
So we multiply.
Okay. 6 times sine 26.3 degrees is equal to 7 sine B. Divide by 7. Sine B is equal to 6 sine 26.3 degrees over 7. To find the final answer, you need to do inverse sine. Inverse sine 6 sine 26.3 degrees over 7.
Why do we have to do
Because you want to find an angle.
that? Oh.
Okay. All right. So now let's talk about this. This is the reason we need to analyze our triangles. Inverse sine, last chapter. Let's talk about inverse sine from last chapter. Inverse sine has a limitation, right? Inverse sine only can give you angles from where to where? Inverse sine.
Oh,
Right hand side. And what angle is that in degrees?
90 and -90.
Yeah, negative 90 to positive 90. And that is the problem with your calculator. Your calculator will only give you angles from negative 90 to 90. If you have an obtuse angle, it will never find it. So if your triangle ends up being with an obtuse angle somewhere, and you are trying to use law of sines, it will never find it. It will always say it's less than 90. So you have to do the work of figuring out, is this obtuse, is this acute, by what you draw. Which is the reason we are doing this whole analysis. Okay, so this is the answer for that question. Let's look at the second one. This is the tricky one. Triangle ABC. I'm gonna draw it this way. A, B, C. Side A is 6, side B is 7, angle A is 30. Same question as before. Is there another way to draw this same triangle? Maybe. All right, let's find the gatekeeper. The gatekeeper is my H. I want to see, can I swing this side 6 so that it could be inside H and 7? Well, that depends on how long H is. So let's find H. Okay, again, we have a right triangle, right? We have a right triangle. I know this angle is 30. Opposite side is H. Hypotenuse is 7. What trig function do I use? Sine. Yeah. Are you still with us? Okay. So sine 30 degrees is H over 7. So H is equal to 7 sine 30. Okay, so figure out what H is. If you remember sine 30, it will be very fast. 3.5. Okay, so is 6 between 7 and 3.5? Yes, yes. So there are two ways to draw this picture. 6 is either outside or 6 is inside. Notice that if 6 is inside, this angle is now obtuse. If 6 is outside, this angle is acute. So that means your law of sines will only be able to find this acute angle. It will never find this obtuse angle. Yes?
Wait, why can you draw that way?
Because 6 is smaller than 7, but bigger than 3.5.
Oh, okay.
Oh, yeah. So we need to change the graph.
We need to solve for two triangles.
Oh.
Yes.
The law of sine never.
It can never find any angle that's bigger than 90 because of the inverse sine restriction. All right, we need to solve two triangles. Let's do the easy one. Just use our calculator, which is the big triangle. And then we are going to use that to help us find the small triangle. Big triangle. A, B, C. 7, 6. This is 30 degrees. Okay, this one's very easy. Just use law of sines. It will work as is. Okay, so angle A is 30. We don't know B. Side A is 6, and then side B is 7. All right, go ahead and figure out the missing sides and angles. All right, so let me give you the answers. Angle B is 35.7 degrees, and then angle C is 114.3. Thank you. And then side C is 10.9. Okay, now let's talk about the other triangle. The other triangle, notice that A, B, C is like this. A is 30 here, 7 is here, 6 is here, but B is in a different position. How are we going to find B if the calculator will only give us numbers smaller than 90?
Use another calculator.
You can design one. We are going to utilize our original triangle.
Oh, and use and draw a straight line.
Well, let's talk about it. Bless you. How long is this line here? This dash?
7.
Hmm?
Oh, 6.
6. What is this angle we just found? B.
Oh, B,
35.7. Let's talk about this special triangle here. What kind of triangle is this one? Starts with the I. Isosceles. What do we know about isosceles triangle?
Two angles are the same.
Two angles are the same. So what is this angle here? 35.7. Yeah? So how big is B? 180 minus 35.7. Stay with us. Okay. So in this other triangle, angle A is still 30. Angle B is 180 minus 35.7. That is 144.3. You can see how your calculator is not going to find that number. Angle C is whatever is left over. A is 6. B is 7. Now C is going to change because C is a lot shorter. Okay, so go ahead and figure out both C's. Okay, angle C is 5.7 and side C is 1.2. All right, next one, I do need you to talk to your partner. Determine the value of B that will produce the number of triangles if A is 10, B is 42. All right, what are they talking about? There is a triangle A, B, C. B is 42. A is 10. The question is, what is side B? What is the value of B so that you can create two triangles? What is the value of B so that you only have one triangle? And what is the value of B so that there is no triangle? Notice this is again a side-side angle situation, and that will depend on the altitude. Because that side B can move. Right, so it's going to depend on the altitude. All right, work with your partner. What does B have to be so that there's two triangles? What does B have to be so that there's one triangle? And then what does B have to be when there's no triangle? Okay, so no matter what you do, it really depends on the altitude, right? So altitude is, that's going to be 10 sine 42, I believe. So that is 6.69. How are we going to create two triangles?
A bigger than B bigger than 6.69.
What? 8? You mean B?
10. A is 10.
What's A? Why do we need A?
Small a.
Small a is 10, so
10 greater than
okay. 10 greater than
B
B,
greater than
6.69. Yes. So basically B has to be in between 10, which is the longest side, and then the altitude. How can we create one triangle? B is greater than
10.
only greater than 10?
And equals to
No, greater than or equal to 10. If it's equal to 10, it's an isosceles triangle.
and equal to 6.2.
Right, and then B equals to 6.69, which is the altitude. How can you create no triangle?
Shorter than 6.
Shorter than 6.2.
Yes, correct.